All right. Good afternoon, everybody. I just noticed that there were quite a number of people, a number of you that were waiting to be late. I do apologize. For some weird reason, I think the default option for is it Google Meet is you know how there's this configuration detail where you specify you can specify if you want if you want this meeting to be open, right? I don't know if you guys have used have configured Google Meet, or perhaps most on the receiving end. So if you look at host controls and then you go under meeting access type, it turns out that the default is always trusted, right? So it will only let you in if you're from a trusted domain. So in most instances, if you're trying to log in using an unza is it sc.zm email address or something, and then if you leave it open, everybody can join ideally, right? Which is what I personally would prefer the default option to be. But in any case, we shall proceed. I will ask for the usual. I'd like to kindly ask if one of you could hear me. Well, I suspect you can see me, or you can see my screen at least, but can you hear me just fine? Wonderful, wonderful. Thank you very much for confirming. All right, so we are going to proceed. I'm not sure if people have had a chance to think about the things that we discussed, when we met last time, but we actually started our discussion of OpenGL, right? What exactly it is, because I think in the recent past I've been mentioning the fact that OpenGL is an API. So we in fact reminded ourselves of what an API is, and we realized actually that it turns out that your quote-unquote OpenGL is similar to these popular web application level APIs, is it? So things like I don't know if people have heard of the Open Archives Initiative Protocol for Metadata Harvesting, or APMH. If you go to the UNZA website, you have access to this application programming interface, right? And really the way you interact with this is just like any other API, right? Because it facilitates machine-to-machine interactivity. If I decide to use the list records verb, for instance, what I can actually do is I can essentially use tools like curl, for instance, to try and pull, to pull data automatically from the UNZA repository in this particular case. And you notice here that because this facilitates machine-to-machine interactivity, the same things that we're teaching you when you're being introduced to RESTful APIs, the structure of the data is the same. Structure is important, right? There's always a protocol and there's a structure. So we realize really that when you're dealing with quote-unquote hardware APIs, the idea is more or less the same. We're trying to, the only difference is we're trying to get through to the hardware itself. Okay, so it's almost as though you're interacting with system software in this particular case, and not really application software. So you're at the same level as the operating system right here. Okay, and then we realized that there are in fact quite a number of hardware APIs. It's just that I don't know if you've been introduced to these things, but I suspect you have been. Maybe not. I don't know. Certainly, these things were discussed when you were looking at the computer architecture, especially when you were introduced to this low-level programming language called assembler, right? So in essence, with assembler, what you're doing is you're literally adding. Let's say you're adding numbers. You're literally adding those numbers at a very low level, right? But anyway, so there's no abstraction. There's very little abstraction at that level. Obviously, I mean, the layer that has no abstraction at all is the machine layer, is it, where you're working with ones and zeros. So your assembler is actually a notch or a level above the machine layer, right? But nonetheless, we're going to continue our discussion. I imagine everything was clear yesterday. We had fun, kind of like discussing things like the what do you call this? The I don't know if it's the one here, but we had fun discussing. I think we had fun discussing the other. I don't know what that is here. These other OpenGL. I mean, these other graphics APIs, right? Because it turns out that you know what's happening here. It turns out that OpenGL is not the only one. I snuck in something else, by the way, that is kind of like tied to Apple-based machines, if you will. So there's an API called Metal. Now you notice with Metal and Direct3D, DirectX API that they're platform specific, is it? So you'd only be interacting with those APIs if your goal is to write applications that are going to run on those particular platforms. You know, sometimes it's a good thing, sometimes it's a bad thing. It's a good thing because turns out that adoption of some of these devices, like Apple-centric devices and Microsoft-centric devices, is quite high, right? So you'd still be able to really build applications that would probably make you quite a bit of money or something like that. Okay, so we did that. Now we are at a stage where I wanted to kind of illustrate a couple of things here, right? In particular, I don't know if people are joining here, but in particular, I wanted to. I mean, your interest here should be, well, if I'm going to be, you know, writing programs that kind of interact with the OpenGL application in order to get through to my hardware, like a graphics processing unit, for instance. How exactly do I check, right? How do I verify that I actually do have access to this API? Well, it turns out, right, because this is cross-platform, it turns out that quite a number of these computers, for instance, or devices, will actually have a corresponding implementation. Remember, OpenGL, this is important here, OpenGL is a specification, all right? Is it driver manufacturers are the ones that are going to come up with a corresponding implementation, right, of that specification. I do hope that you know that is making sense here. So, like in my case, actually, what I'm trying to hint at here is, in my case, I do know, or at least I somewhat have an idea that I have access to OpenGL. You know, API here, and a series of commands that kind of go through here. But I can run commands like, you know, glxinfo, for instance. In fact, if you do a man on glxinfo, it kind of explains what that is all about, right? So it's showing you information about the GLX implementation. You know, at some point here, I guess it's mention of the fact that the GLX program shows information about the OpenGL and GLX implementation running on a given X display. Okay. So I can do a couple of interesting things, and I think I have some commands that I'm going to showcase an example. So if I run glxinfo, for instance, I have access to a whole slew of information that will give away details about OpenGL, right? Anyway, so you'll notice in some of my slides that I'm doing things like, oh, we can grep for the version to try and see the sort of version associated with this implementation of OpenGL. In this particular case, I'm just going to say open sort of there was output here. So in my case, it's 4.6, for instance. Well, so it turns out that with if you're working on Ubuntu like I am, for you to be able to interact with, or for you to be able to run commands like, is it glxinfo, for instance, or indeed to try and verify that OpenGL has actually been installed with hardware acceleration, there's a couple of commands that you can run. And you know, when we had class yesterday, after we had class yesterday, I looked into, because I was curious, right? It becomes abstract if I'm just talking about this and showcasing to you, oh, this is what you do on your machine or something. But what if you wanted to quickly do this? I've added some slides, and I think I'll convert this into homework or a lab or something to be lab 0, where you can go and play around with your phone and try and see if you can replicate what I'm going to showcase. So in the case of Ubuntu, right, or any variant of Ubuntu, really, what you just do is you can take advantage of apt-get. So you do a sudo, apt-get. Of course, you have to update first, right? And then you can do a sudo apt-get install method utils, right? So this will give you access to, because I've already installed them, I don't think utils, anything will happen here, right? I've already installed these things here. So this is what you do, right? So I've already installed Mesa tools, or already installed Mesa tools, I guess. And what this does really is it gives you access to interesting command line tools like GLX info, which I just showcased. Because when you run GLX info, it actually outputs quite a lot of information. If you notice, if I do GLX info, for instance, and just run this, there'll be a whole bunch of output here, right? It's a lot actually, such that if I scroll the way up to the top, some of it has actually been overwritten. In fact, I can probably do a more or something, I don't know. The idea of just how verbose all of this is, right? But what's important, I guess, is you can grep for specific information, like the version in this particular case, right? Is what I grep for. So if I do, I'm just going to clear the screen here. If I do GLX info / grep, open GL version, it tells me the version. What I did was I'm gonna preempt some of these things here, because you see now, because I'm gonna have to preempt some of these things here, because guys, I know how it's like when you're looking at abstract things sometimes. So showcasing things that help people to understand concepts sometimes may be the way to go, if you will. So what you can do on your Android, I think I'd mentioned this, but I've added this in the slides, but you can install a tool called Termux, right? When you install a tool called Termux, what you have access to is something similar to what you're seeing on the screen, right? And I'm just going to open Termux here. And so when you install appropriate tools, I don't know if this thing is going to rotate here. I want it to rotate or something. So what you would actually have access to, sorry about that. I'm just going to zoom in here so that you're able to see these things. Unfortunately, right, when I'm using screen copy here, I can't write commands like right here. So I'll have to type them in on my phone, which is horrible sometimes, right? So just clear the screen here. And remember, Android is what? It's a Unix-like operating system, right? Actually, Android is a fork of Linux. So commands that you'd run on Ubuntu would typically be able to run on Android. Although, granted, in this particular case, what I have done is I'm using a terminal emulator called Termux. The only other way I could get around this is maybe if I use ADB or something, right? I know people have used ADB, but that's neither here nor there. So it turns out you can run commands via ADB. In fact, if you run ADB and shell drops you into, or you're dropped into the shell for Android device, you can then run some of these commands. But anyway, in this particular case, I'm running an emulator, and so the commands, right, that you'll be able to run like I am here, can do GLX info as well. You notice they're the same exact commands, right? I don't know why it's unable to do this. So I'm just going to see if I can. Okay, that's fine. I don't know why this thing is overlay as well. It's horrible, is it? It's going to kill it like that. And then I will have to start the VNC save, I think. I don't know why this thing is fading all of a sudden. The thing is, I was doing a whole bunch of things here, right? So, and I have to export the display, I guess, also. such a shame if it fails here, but if it fails, you can always do this as homework or something like that, right? There we go. So you notice that, and again, the output is somewhat similar, right? Because it's a lot of output. I mean, I could probably scroll somewhere at the top here. Because the output is too much, what I would do is I would more or less like do the same thing I was doing on my computer, is it? My computer shell. So I could, I'm just going to clear this, and I could say clear. You know, I literally have got to use my my forefinger here to type, right? Because the thing is in landscape here. So touch typing is a bit difficult. But anyway, so what I could do here is I could do a glx info. And this is what you should be doing, actually. You should be experimenting with this as well. I expect you to do this lab 0 or something. And then what I'll do is can I grep for the same command essentially I was using, is it? I'm just grepping for the OpenGL, and case is important here because I'm grepping for a script, for a string. So GL, there's a version here or something like that. This is a thing, the pen of no autocomplete here in the shell. So in this particular case, you notice there's a difference here, slight difference, right? My 1+ 9R is a relatively older machine. I think it's clocking 2 years this year or something, or is it 3 years? But my laptop is relatively newer, right? This is like a ThinkPad T4 or something. So my version, right, of the version of right, of OpenGL. The version of OpenGL on my laptop is this. OpenGL. Yeah. Right, it's like 4.6, is it? But the one on my phone, on my OnePlus 9R is actually version 4.5 or something like that, right? So we see here that there's a couple of interesting things you can do here. So you can look up the if you install these utility tools. Of course, if you're using Termux, you're going to have to go through a different set of instructions, and I think I provide those details. I provide those details in the slides at some point, right? So you can also check the OpenGL vendor, right? So again, if I come back to here and I say I want to grep for, I want to grep for vendor or something. I'll just say VE because version vendor is VE, right? So that we see both the vendor and the version or something like that, right? And we see here that the vendor is Mesa, right? It just makes sense. It's the same as not that these are important things really, but it's the same as here, is it? I grab the version here. This is Intel, right? Okay, so slight variation here, slight difference, right? What else can we do? Well, yeah, we can actually we can verify, right, if our system has OpenGL installed working with hardware acceleration. I don't know about that. So again, you can grep for direct rendering in this particular case, right? Let's say rendering, I guess. Let's just see here. So direct rendering is true here. I don't know about my phone here, but I can check as well. So I'll just say again, I'll just grep for rendering or something. I'll just render. I think it's yes as well. I suspect. Oh, you see now. What? Control C. Okay. Now I use the single quote instead of double quotes here. Yeah, so rendering for, you weren't seeing what I was doing here. Rendering is also true here, right? On my mobile device. This is my mobile device, is it? If you notice here, direct rendering is equal to yes. And what you can do is you can verify when you install the Mesa tools on your computer, for instance, you can just run glx gears, right? The glx gears command comes bundled with the Mesa util package that you would have installed. And I believe when I was fidgeting around with Android, I think I also installed, is it Mesa demos or Mesa utils as well? You can always verify the slides here. So the idea behind the what you call GLX gears is it kind of renders kind of like a visual representation of a series of gears or cogs, right, rotating, so that actually confirms that seems trivial here, but this confirms that I don't know if people can kind of see what is on my screen here, but this confirms that OpenGL is actually installed with hardware acceleration ideally, right? If that makes sense. Okay. Anyways, I don't want to waste time here showcasing escape or exit, drop you out of here. I don't want to waste time here explaining how this would probably like work on Ubuntu, but it does work. You essentially on Android rather, it does work. So the same thing happens, right? When you run the GLX gears application, the 3 cogs will pop up and then they'll rotate, and then you've confirmed that OpenGL is installed with hardware acceleration ideally. So like I said, going forward here, next series of 12 slides are just I included this so that they'll help you accomplish lab 0. I will put up lab 0 on the Moodle, right? It's a simple task. All you're supposed to do is, using your mobile device, you are going to install Termux, this terminal emulator, very easy to install. And then you're going to go through a series of, I'll be honest here, I mean, I stumbled a bit here when I was trying to run GLX info on my Android phone, right? It turns out that there's a series of things that you've got to do. Like you've got to, first of all, install certain packages before you can get access to that, right? So there you go. I had to install Mesa tools, sorry, Mesa demos, not Mesa utils. So you notice that on Ubuntu, it was Mesa utils. On Termux, it's Mesa demos, I believe, right? So installed Mesa demos, and then you've got to, because when you run it for the first time, it actually won't work, right? You need to first of all kind of like install a display, right? Like so when you drop into Termux, it's more or less like you're just working on the terminal. So think of what usually happens when you are using SSH or perhaps Telnet, for instance, those really weird protocols, where in most instances you'd be working on the terminal because you are interacting with a remote machine. So the way Termux works is it views the actual host as like a remote machine, if that makes sense. And if you remember, when you're working with a remote machine like that, it's not a trivial thing for you to see an output, right? Of course, I mean you can probably use certain types of applications like remote desktop viewers, for instance, to be able to see a graphical representation of the computer that you're accessing remotely. So the same applies here. It turns out that you have got to install a VNC viewer. So I managed to actually install Tiger VNC on my Android phone within Termux, by the way, right? And then once you install it, the very first thing you've got to do, obviously, is you've got to run the server. I think you noticed when I was trying to run GLX info, the GLX info command, I got an error initially. And I don't know if you were able to, if you remember what was happening here. I got I don't know where this is here. Is it this? I got, now you see now we're in the screen here. But I got, I don't know, exit here and come here. But I got an error initially, right? When I was attempting to run GLX info, because I hadn't yet started the, let me close this off here. I hadn't yet started the VNC server, is it? So you've got to do that, and then afterwards, for you to be able to, I mean, so you can run GLX info quite right, which is what we did, but for you to see, let's say, output, right? The actual window with graphics drawn, GLX gears in this particular case, what you have got to do is you've got to obviously install VNC viewer. So what I did myself is I installed this viewer here, right? It's called it's called RVNC viewer or something. I'm sure there are better viewers, but it's one of the things that popped up with the most with the most hit or something like that on Play Store. So if I start, but why? If I start this viewer, doesn't matter. I'm running locally. It's 1, 2, 3, 4, 5, 6. If I start this viewer, you notice that I will have like I'm seeing the output on my Android phone. It's like it's a remote machine, right? So what I can then do is, but why not? From here, I can say, this is insane, is it? From here, I can say, I don't know why this is, there we go. From here, I can come here, right, in Termux and run GLX gears, right? GLX gears. And once I run GLX gears, of course, on the terminal is going to be showing you the frame rate, right, associated with the visualization itself, right? So 250 frames per second, FPS, if you remember our discussion of this. And if I go back to this view, I'll be able to see the gears as well. So literally these gears on my Android phone, of course, I mean, it is my Android phone, is it? You can literally see 89%, and the time on my phone is like 13:31 or something like that. And this is anyway. So in case you want to play around with these things here, you check out the what do you call this? The version of OpenGL on your phone. Your task is to install Termux. I'm going to dump this as as an assignment, right? So you install Termux ideally. After you install Termux, you then need to install Mesa demo, the Mesa demo package. Now, what you begin to notice is that in Termux, you don't run the same commands you run on Ubuntu or Linux, right? Like apt-get install, for instance. You actually run pkg, right? Package install. So pkg install, pkg, uninstall and all those things. So pkg, just take note of this. But the slides have the commands clearly laid out here. So you ultimately be able to actually check these things as well on your phone or something like that. Okay. Now, just mention here that it turns out that OpenGL again is not a single program, right? We've mentioned it. It is a specification, and what I'm seeing on my phone and on my computer is an implementation of that specification, is it? Right? And the implementation is manifested as part of what we call the graphics drivers, ideally, right? Low-level instructions. Again, Ubuntu 24.04, which is the version I'm using, comes with Mesa open source drivers for Intel, AMD, and NVIDIA, right? Already pre-installed. I can't remember if they were pre-installed or I had to run, apt-get install Mesa utils. And I'm saying I can't remember because when I was creating these slides, I was able to directly run GLX info and GLX gears, right? So it turns out if you have an NVIDIA GPU, you may want to install proprietary drivers specific to NVIDIA, for instance, better performance. And what you probably have to do in that particular case is just look up instructions on how to do this. And then the specific packages, right, that will provide the development headers and utilities. These is associated with your device drivers, not that it's important. And so we see here that at the driver level, the OpenGL ideally communicates directly with the hardware, is the GPU. However, at the application layer, in terms of what we're going to be doing in CSC 4505, the wrapper or the binding, the PyOpenGL, is going to provide us with mechanisms to enable us call these driver functions. So in fact, what we'll be doing is we'll be calling the functions that are outlined in the specification itself, bearing in mind that the specification was implemented by the device driver manufacturers. Okay. Yeah, I guess another command on Linux. This is on Linux. I have not tried it on. I'll try it on my phone actually. So if I wanted to check what sort of graphics hardware I have, right? LS PCI is it? And then I grep VGA or something, right? So in Intel VGA in my case. I don't know about my. We can check what is associated with my my phone here. I'm just going to. This thing is still running in the background, is it? You notice the frame rates and stuff and number of frames. So I will just cancel this, okay? And then I will just going to up down here. And then I will. I don't know if it is PCI here. Come on, really? LS PCI. I have to mute these things, is it? LS PCI, just it's horrible. Grep PGA or something. Sorry, I'm a bit slow here. Yeah, I don't know what's happening here. It's refusing, it appears. It wants me to. I don't know if I can even run sudo here. It says just do a root here. That's sad. Anyway, I can always try it out later on. I just wanted to find out the device manufacturer, but that's fine. The graphics hardware that I have on my phone, but that's fine. So you can do that. And again here, in terms of the architecture, what we're going to be doing here, we see that the Python scripts we are going to be writing, and remember these Python scripts, it's only possible for us to write these Python scripts in certain phases of the OpenGL pipeline, right? Those shaders, these Python scripts ideally are shaders, right? So we see that the scripts will use the binding, the PyOpenGL binding, right, to call the OpenGL functions. And then these functions are ideally supposed to be routed to the actual OpenGL API, okay? And then the API is the one that ideally interacts with the device driver, right? Finally, this device driver is going to translate all those commands into equivalent GPU instructions ideally. And then finally, the GPU is going to execute the rendering, right? It writes it to the buffer, which ultimately is going to be displayed onto your monitor, your screen, right? So a visual representation of this process. Our goal here is to learn how to write, these Python scripts at this level, right? Everything that happens afterwards is abstracted away from us. In fact, we don't really care, right? We just need to learn how to efficiently construct these Python scripts in our case using PyOpenGL, okay? And so the question really becomes, well, so how exactly then, right, is OpenGL used? How do we use OpenGL? And I've already started giving out, hints on how this thing is supposed to be used here. I was giving away some commands and all that. But it turns out that fundamentally, we'll be using OpenGL, specifically PyOpenGL, to draw things, is it? Right? Now, what you begin to notice, similar to your introduction to MIPS assembler, for instance, in second year, when you're writing assembler code, similar to that, you notice that these functions are small, right? But very powerful, right? If you remember your MIPS assembler, it's based on a reduced instruction set and what did they tell you? How many what did they say? How many operations are associated with MIPS? Do we remember from second year? I know you probably did, you probably worked with just a select few, right? Do you remember the total number? The reason why it's called the reduced instruction set, do you remember? Hello? Can you hear me? Hello? You guys should be serious with life. I guess you can remain quiet and because nobody's going to ask you how many instructions, at least not in CSC 4505, how many instructions I need. assembly. There should be less than 200 or something. And I don't know if you remember your R instruction types, your immediate instructions, right? There are those register instructions, is it? Like your add instructions and stuff, and then there are immediate type instructions, right? Where you combine a variable and an actual number or something like that. But the key thing here is, don't have to remember that, that's fine. You can look it up afterwards if you want to. But the key thing is, the idea is the same there, right? Because you have the very low level, is it? When you abstract things a bit more, sometimes you write instructions when using high-level languages, right? You write instructions that will have human language notations in there. You know, like print. There's nothing like print in MIPS assembler, for instance. But anyway, the key thing here is we see that the API itself allows us to draw things, that's key. And we'll be able to draw these things because we have access to small but very powerful low-level drawing operations, okay? Unfortunately, right, the OpenGL does not have functions to create a window, because if you're saying you're drawing things, you've got to draw those things somewhere, is it? On a canvas, yeah? And because there's no window, this is the reason why I said that in CSC 4505, we are going to use the PyGame library, okay? So it is going to enable us to draw this window itself, so that we're able to kind of open a window, we can close it, right? Using that X or something, we can minimize it, we can maximize and all that. And just to mention here that there are alternatives to PyGame, right? So PyGame is not necessarily the only Python library that you can use to create these so-called the window itself, right? The canvas where you're going to be drawing these sort of things here. There are quite a number of other, a couple of other packages, I guess, Piglet, for instance. Anyways, so there's that. And then just to mention here, right, you will see a lot of these things pop up, yeah? So things like when we're writing the PyOpenGL programs, you will see commands like GL vertex 3F or something like that. I thought I would mention some of these patterns, right? So that it's immediately intuitive once we start doing this, is it? It turns out that what's key here, if you look at the pattern of these 3 example commands there, is such that there's a number of components, is it? Either 2, 3, or 4. So these things that you are seeing in this particular case, GL vertex 3, GL color 3, right? GL vertex 2, is it? So the number of components, right? In essence, the number of components, you can view them as parameters that you're feeding to this function. So if you notice, GL vertex 3F here accepts how many arguments? 3 arguments, right? That's 3 parameters, X, Y, Z, the coordinates, right? X coordinate, Y coordinate, and Z coordinate, if you remember, because we're working 3D in this particular case. So in other words, if you want to create, in this particular case, you want to create a vertex, right? A 3D vertex in space, in model space, I suppose. You can run, or you can invoke the GL vertex 3F function. Now, the other thing that you find in the suffix, like what comes after the name of the we call this a function in this particular case, is the data type, right? So wherever you see an F here, it means you're dealing with 14-point numbers, is it? Decimals, ideally. If there's an I, it's integer. If it's a UB, it's unsigned byte. You will see us using a lot of 3F and perhaps 2F in some instances, right? And 3F, or 3F and 2F, ideally. If you see a V, right, it means you're dealing with a vector, is it? So if you notice, if you look at this particular example here, we're feeding it an array, ideally, or a list, okay? So hopefully this would be, you won't get lost when we're doing this here. And then also, I mean, there are certain key, state setting functions. Again, I've mentioned this before, I'm going to mention it again. We are predominantly going to be doing this using legacy OpenGL, right? So don't get confused when you're reading up or when you're researching this and you come across code that is, it really veers off to what we're going to be looking at in class, to to simplify things, we'll be using legacy OpenGL, ideally. Okay. So some example functions here. If you look at GL color, for instance, right, state setting functions, you'd be able to use this function to set the current color. GL vertex will allow you to specify a vertex, right, in immediate mode. And then functions like glx begin, which has a corresponding glx end, allows you to define these primitives we discussed, is it, in immediate mode, right? So let's say you want to draw a triangle, right? You know that a triangle is going to be made up of 3 points, right? So what you do is you start with GL begin, right? And then you have a GL underbar triangle or something. And then at the end, you have a GL end, right? In between these two commands is where you'll be specifying these 3 points, right? So you have a GL vertex 3F or something, and then you have a position for vertex 1, right? In space, you have a position for vertex 2 and position for vertex 3. And obviously, you know, OpenGL is going to know that if this is a triangle, then I need to have 3 edges, right, that are going to interconnect these 3 points ideally. Okay, so there's that. Again, hopefully we shall not get lost when we start looking at the code here. But it's simple code, I assure you. It's not that complex. I think, I don't know. Maybe at the beginning it may seem strange here, but also, you know, because there's a couple of things in the mix here, right? You're not just looking at PyOpenGL here. There's like NumPy, there's PyGame, right? There's PyOpenGL Accelerate, but of course, I mean, PyOpenGL Accelerate is, you don't use it directly, right? It's ideally invoked by PyOpenGL. It's meant to ensure that the execution of operations is much faster, ideally, in the GPU. But anyway, so a reminder here, in terms of the coordinate system, right? If you remember, when we were looking at the logical, especially the logical pipeline, there was mention of a series of coordinates, is it? Coordinate systems that we're using. And I want to draw attention to something interesting here, something that precedes what we introduced as screen space, right? We mentioned that we ideally find ourselves working with what's called normalized device coordinates at that level, right? So that we're able to project whatever is on canvas onto different screen resolutions, right? It could be a screen resolution that has an aspect ratio of 16:9, maybe 4:3 or 1:1 or something, if there are people that still use that, right? But a reminder here that when we look at those 6 spaces we discussed in the logical pipeline, when we're dealing with model space, we are dealing with local coordinates, which is why sometimes it's called local space. So ideally, each object has its own pivot point. Okay, that's good enough. So this can range, is it? It could be like ranging from, although is it negative infinity to positive infinity, if you want to look at it from that perspective. And then you have world space, right, where we are placing all the objects here into a common coordinate system, right? Again, the range of values here can probably range to negative infinity, positive infinity here. And then we have, view space, where we are using the coordinate system that is relative to the camera itself, right? View space or camera space, if you remember. And then you have clip space. But more importantly, we said that in step number 5, you have what's called normalized device coordinates here. At which point you are squishing everything within the range -1 to +1 in all axes, right? In all 3 axes, ideally. And then that will be projected onto specific screens that one will be using. Now, a key thing to note is that OpenGL will enable you to directly provide your vertices in normalized device, using the normalized device coordinate system. So meaning that these values that when we're evoking functions like GL vertex 3F, for instance, you will not see things like 3,2,1, right? Or 3,2,4. It will be values in between -1 to +1 ideally. Okay? So working in NDC ideally, I would mention that. Okay, so now that we've gotten that out of the way, I think it becomes important that we briefly discuss the Python stack we're going to be using. we all know how to program in Python. Apparently, you are taught how to program in Python. Is it in second year or something? And if it's third year, you are doing some machine learning course. That's neither here nor there. In case you want the motivation for Python, I already hinted at why we're using Python here, but it's easy to learn. And our focus here is to understand OpenGL, right? We don't want to struggle with the programming language we are using, which is why we tried as much as possible to stay away from C++. So we'll be able to write our code much, much faster. You'll see this, right? And our goal is to just focus on the logic itself, right? The logic specific to the API, the OpenGL API, rather than things that are specific to the base programming language, okay? But in addition, we see that Python actually has become so very powerful in that a series of modules that we can use in the process. In the case of what we're going to be using, for instance, it's a lot easier for us to draw things on canvas because we have access to a number of libraries that we can use, and we've chosen PyGame, right? When we are handling matrices, when we're drawing these points, we'll be using NumPy, right? Numeric Python, ideally. So Python will enable us to implement, these computer graphics concepts in a relatively shorter period of time. But again, I mean, there's other motivations. We see it, being popular in certain types of sub-disciplines of computing. Like if you look at things like data science and, machine learning, for instance, there are frameworks specific to that that are Python-centric. So frameworks like, Keras, PyTorch, and TensorFlow. Anyways, so there's that. Now, in case you've forgotten your Python, just a reminder that Python is an interpreted language, right? And because it is an interpreted language, for you to be able to see the things, or for you to be able to see your code in action, you need to have an interpreter installed, is it? Right? So the idea behind an interpreter, if you remember, is if you compare it with a compiled or compiled language, the idea behind an interpreted language is simple. Code is executed line by line, right? In real time, ideally. So every time you want to execute a program, you need the interpreter, ideally. Compare and contrast with the compiler, where you use the compiler to generate something that is device specific, right, or platform specific, typically something like a .exe file that the user is going to double click and then install onto a machine. So the first thing you need to do, obviously, you need to install Python, right? So if you're using Ubuntu like I am, it will be something like this, right? This is how you test that you have the interpreter. Or you can run a command like python -- version or something to check the version of Python. So that's that, right? If you just Google up Python or something, you go to the Python website and you can download Python for a specific version of the specific type of operating system that you're using. But more importantly, like I said, there are specific, libraries that we're going to be using in this course. So there's supposed to be 4 key libraries, right? 4 main libraries, not 3, that are going to be using. So it's PyOpenGL, and then there's PyOpenGL Accelerate, there's PyGame, there's NumPy, right? The reason why I left out PyOpenGL Accelerate is because it's used implicitly by PyOpenGL. Although when you're installing these packages, you have got to install PyOpenGL Accelerate, right? So it's in the module called PyOpenGL under Accelerate idea. So PyOpenGL is going to provide us with Python bindings for OpenGL, so that, like I said, we can write our Python code and interact with the OpenGL API. And then PyGame will enable us to create the window where we're going to be writing these or drawing these different things, primitives, right? Vertices and edges and faces and all those things. And then NumPy ideally will allow you to allow us to create these, and I have an explanation actually here. Allow us to create these matrices that we'll be working with here. Okay. So just an explanation, same thing I was talking about here, right? The only thing you need to know here is how to install these things, right? What we may end up happening is towards the end, I think there are topics that will require that we install these additional packages like Pillow, for instance, but we'll confirm this as we go on, PyGLM and Matplotlib. But the core packages we're going to focus on are these 4. PyOpenGL, PyOpenGL Accelerate, PyGame, NumPy, right, for them. Now, I thought, showcase, not that it matters here, but the examples I'm going to be illustrating are tied to specific versions of these libraries. Generally, if you install them right now, no likelihood you probably end up with these same versions of the packages, right? What I have done, however, is what I'm doing myself is I work with Python environments. It's much easier that way because I do a lot of things on my computer, right? So I've created an environment for 4505. I'm sure you remember your discussion of environments in Python, is it? And they told you why you need to do this, right? So if you're like Lighton and you teach for a living, you teach graphics, you're teaching data science, and you're teaching data mining, you begin to realize that you will probably find yourself using different versions of these software tools because some libraries may not be compatible with more recent versions. So what do? You create separate environments for these different different courses in this particular case. Although in my case, right, the environment, the Python version that I'm using for the graphics course is ideally the same as this one as well, right? I don't know if I have this. Maybe I do. As the environment for this course, right? The data science course. The only difference is if you look at the packages I have installed in the data science course, I have slightly more things here than what I have here, is it? Piplist or something. Just to mention here that what I would do, not that it matters, but maybe it will matter, I will actually do a pip freeze, and I will put up a requirements.txt file, right? In case you want to have access to this. So I will upload this onto the Moodle so that when you set up your environment, if you remember the way Python environments work, if you set up your environment, all you do is PyGraph thing here. I don't know if you remember, not that it matters really, but what you do is you create your environment first, right? And then after you create your environment, you can then you can then install those packages, right? So you can install them using the requirements file, is it? In this particular case, it is a Python 3. There we go. And then I want to create a folder called this, and I will call it, it's a prompt here. I'll call this thing, because I want to delete it afterwards. I'll call this CSC4505 sample environment or something. So you do something like this. So I'm creating an environment in here. When I create this Python environment, the Python interpreter will be installed in there, is it? I don't know if I've left out something here in terms of the command. I don't know why it's taking a while to create this. There we go. Took a while there. I don't know if it's a connection. I hope I'm still connected. But what typically happens is that in this hidden file here, the .venv, if I go in here is where my Python is installed, is it? So this is where I'll probably find the Python interpreter here. Right. So this is specific to this particular environment, right? It's only accessible in this environment. And they told you that what you do with this is, for you to activate this, you just do something like this, is it? Right, so that you notice here at the beginning, I only have Lighton period, I think, by T14. But when I activate this, Python tells me to say I've dropped myself into this environment. And when I'm in this environment, if I check pip list, I do not have, I only have pip installed here. That's the only package I have, right? To enable me to install these other packages. Now, when you create an environment like this yourself, what you do is you download the requirements file. Come on, really? The requirements.txt file, this file here. And then what you do is you'd say pip install. The requirements file is that. And this thing is going to go out there and just install all of these, in this particular case, these packages that I have in my requirements.txt file or something like that. Okay, so once you do that, you will have the same exact setup I have. And if you want to replicate the code that I'll be sharing, everything should be able to work, right, without a problem, ideally. Okay, obviously making sense here. Now, obviously, a couple of things that you're going to have to do here when you set up your environment. I'm going to ask you to maybe stick around here because I would also I would want to get you to a stage where you're able to actually set up this environment and test them out. So once you do this and you activate your environment, you can test these things, is it? And if you remember, there's ways of testing the Python packages, is it? With your interpreter, the easiest way of doing this is you can import the package. So if I've managed to install PyGame, right? I can import PyGame, is it? When I import PyGame like this, or hello from the PyGame community, I can actually check, right? The things that are available, objects available in PyGame with a dir built-in function. I can also look up, PyGame using the help built-in function, right? So if I do help PyGame, I have access to, documentation to do with PyGame. It tells me that PyGame is a set of Python modules designed for writing games, ideally, right? So it's written on top of the excellent SDO library, blah, 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 and stuff. So PyGame is working. I do the same thing with NumPy, right? I just do an import NumPy, right? And then I can do a dir NumPy to check the things associated with NumPy. I'm just verifying that NumPy has actually been installed. And I can also, I can look up the documentation, is it? So I use the help built-in function to look up NumPy. I know it's taking a while here, and I see that NumPy is installed. It's telling me that this is what NumPy is all about here, an array object of arbitrary homogeneous items and stuff. Anyways, so there's that. And then I can also do a dir. Now there's something interesting. If I do the dir, there's something interesting about PyOpenGL. Observe. I'm going to say exit here, right? And say, well, keep list. Which libraries do I have here? Well, and I have PyOpenGL, PyGame, and NumPy. And intuitively, you want to sit there and you're like, okay, if I've installed PyGame and I'm doing import PyGame, if I install PyOpenGL, then what I've got to do is, look at this. I've installed NumPy. I do import NumPy. I've installed PyGame. I'm going to do import PyGame. Okay. Well, I've installed PyOpenGL. Then I'm going to do import PyOpenGL. No, it won't work here. Right? What you do is you do an import OpenGL. Okay. Just usually at the very beginning you make that mistake, right? So I can do a dir OpenGL, and I see the things I have access to. I can also do a help OpenGL to see documentation on OpenGL, and tells me that OpenGL, this PyGame that I've installed, is a C type based, implemented in C here. OpenGL wrapper for Python, ideally, right? And you can look up the documentation if you want at your own time or something. We're not concerned about the documentation. We know that you know how to read documentation and stuff. Okay, so at the very least, you want to make sure that you test all of these three packages, right? Remember, PyOpenGL accelerate, this thing here. If I do pip list, PyOpenGL accelerate is used implicitly by PyOpenGL. So don't worry so much about this. You just have got to make sure that you install this thing here. Okay. Yeah. Okay. So when we meet next, we're going to have a very, very crash course introduction. I think we're meeting on Wednesday teas. We're going to have a very, very crash course introduction to working with NumPy. And my focus is going to be on things that are specific to what we're going to be doing here, right? How you create these multi-dimensional objects and how you perform dot products of two matrices and all those things. I'm going to pause and find out if you have questions in terms of setting up the environment. I do encourage you to make sure that this environment is set up. If you do not have a computer, at the very least, right, as you're waiting to gain access to the labs, you can actually use Termux to install Python and all these different packages. I know it's a bit cumbersome and tedious, but you can, at the very least, you should be able to execute examples that I'll be providing to you. So I'm going to pause here and find out if there are any questions that people may have. Okay, if there are no questions, that's fine. See you when you see me, I guess. Or maybe there's a question here. I think there's a comment. I don't know if there's a comment or something. No. Oh, sorry to take you back, sir. Are we supposed to download OpenGL and Termux? You don't have to download OpenGL, right? OpenGL is an API. It comes, oh, you don't have to download this. It's an API, right? It's already there. It should be already there. However, you can use operating system to actually install it, assuming the API is already there. If you want to check that it's there, you follow through with instructions, right? You must install Termux if you do not have a laptop and you want to test out these things I was showcasing here, like GLX gears. You want to see if you can render this thing, right? To confirm if OpenGL API is installed with hardware acceleration, ideally, as long as this thing works, as long as GLX gears runs and it's spinning like this, then you know that hardware acceleration is enabled or something like that, right? So escape here. Yeah, let's see what else here. It says, are you referring to the, yeah, so instruction set architecture. So MIPS assembler is a specific type of instruction set architecture, right? It's a reduced instruction set, they say. You know, so you are following through here. How do I access the requirements.txt? I'm going to upload it on the Moodle, all right? All you do is you download that requirements.txt and then you create your environment, the Python environment, and then you just run pip install -r space the requirements.txt. And then does this mean the requirements.txt file is the one that is needed to set up the environment on a piece? Yes. Yes, that is all you need. All right. In case you have trouble doing this, this is why we have the mailing list. You can always send your mailings. Thank you very much, everybody. I'll see you on Wednesday. Please, at the very least, set up this. Make sure you have the two set that, or the two chain that we're going to be using, so that when the practical sessions start, you're able to follow through easily. It's the way that you get to understand the things you're doing is you run these things, you test them out and stuff. Good day. Thank you.